Okay. 1-2A. So today what we're going to do is we're going to be talking about analyzing um, function graphs. We're going to take a look at some graphs, and then we'll be able to kind of look at them and estimate certain things, function values, and then find their domains, ranges, and their y-intercepts and their zeros. So the first thing we're looking at right here is sometimes we can look at the graph of a function, let's call it f. You can determine the function's domain and range, and then estimate their x and y intercepts just by looking at it. We also call, there's some things that we use interchangeably. The x-intercepts of the graph can be called the zeros of the function because these values give an input on an output of 0. So you may hear the following terms, right? X-intercepts, solutions, roots, zeros. They are all the same thing, okay? So let's get into some practice here. All right. So looking at this one, stocks investor assess the average daily value of a share of certain stock over a 20-day period. And the graph is shown below there. Value of the stock can be approximated by that equation right here, by this function. Okay. Keeps going over here as well. Whoa, how did that happen? Keeps going over here. Okay. Where D represents the day of the assessment. So using this graph, taking a look, what do we see? What can we look at? Okay. So the first one says use the graph to estimate the value of the stock on the 10th day. All right. And then confirm our estimate by using algebra. So if we just look at the 10th day here, here's the number of days. We look at the 10th day, we're looking at right up here, this point right there. Okay. So by doing so, we're going to look and say, I'd say that's at about what, 32. So just kind of guessing. I would say the value, say the graph is approximately $32. Okay, $32. All right, so confirm it. We're going to confirm it by using algebra. Okay, so by doing so, we're going to say that we've got the value, right? So we want the value. So let's call it V at the 10th day, and then we can plug in certain numbers. So by doing so, we're going to look at that function up here, right? We had this function right here. So we're going to plug in that function. And for D, we're going to plug in 10. So that's how we would confirm it algebraically. So we'd have 0.002 times 10 to the 4th power minus 0.11, add a 0 over here as well, times 10 to the 3rd power, and we keep going with that, plus 1.77 times 10 to the 2nd power minus 8.6 times 10, and I'm going to run out of room here, but we have to add that 31 at the end, right? Okay. If you compute that, all that math, what you're going to end up with, you're going to see that it does check out to $32. Okay. So that's how we would actually confirm our estimate algebraically, is actually do the math there and get it in there. That's $32. Okay. All right. Part B says use the graph to estimate the days in which the stock was valued at $30 per share, and then confirm this algebraically. So just by looking again at the graph here, we're going to look at, just by looking at the graph, okay, where was it $30 per share? So if I look at $30 per share, well, I could say that on day 9, right? Day 9 is about $30, and on day 15, it looks like, right? And I also think maybe at day 0, right when it started there. So I guess I could say 0, 9, and 15 would be according to the graph. Well, if I do this algebraically, what I'm going to have to do is I'm going to have to evaluate those. So I'm just going to do 9 and 15 because I guess day 0 is where it started. It technically wasn't there. So we're looking algebraically. Okay, what we're going to look at is the value at 9. Okay, the value at 9. is going to equal okay, 0.002 9 to the fourth. And again, it's a large function, 0.001, 9 to the third power, plus third, 1.779 squared. So I'm going to get rid of this stuff here just because we already did that. Okay. 9 squared. I'm going to rewrite this here just because it looks crappy. Okay. And then minus 8.6 times 9 plus 31. Okay. So I'm also going to have to evaluate that at the next one down as well, which was the 15. Okay. So I'll go 15. And it's going to be the same formula, same idea, right? 0.002 times 9, except instead of using 9, I'm going to use 15. The fourth power minus 0.11 times 15 to the third power plus 1.77 times 15 squared minus 8.6 times 15. Don't forget the plus 31 over there. Okay, when we do that math, what you're going to find if you punch all that in is that this one here is going to come out to 29.9. And this one here is going to come out to 30.25. So you notice it wasn't exactly 30, but the estimates were pretty close. We're at 29.9 and 30.25 on those days. So it was pretty darn close there. All right, so let's move on to the next section here. So we're going to use the graph of G to find the domain and range. So if we look at G, we look at our domain, we're talking about the X values. Where does it go to, right? So it includes -2 here. So our domain here, it includes it. So I'm going to use a bracket because it does include -2, and it looks like it goes all the way over here to 6, but we got an open circle. So that means 6 is not included. So that's, I use a parenthesis, right? So again, the brackets and the parentheses are important there. The range, looking at the Y values. Well, it looks like it is included on 0 because we've got that dot there, and it goes up to about 4 at its height. And it is included there. So I'm going to use brackets here, 0, 4. What's the lowest value it goes and the highest value it goes. Okay, so looking at 2B here, kind of the same general idea. Where are these? Now we got 2 graphs and they both have circles, but be careful with what we're doing here. Okay, both have circles, which means we're going to use a parenthesis for the first part. So it looks like I'm here at -4 on my X value, and I go to, looks like +2. And I use parentheses because those are open circles. But then it also includes, so I'm going to use like a union symbol because it also includes an OR value, right? So it's either this part of the graph here or this part. It works. So again with brackets, because it kind of picks up at 2 again and then goes on towards infinity here. So I would put 2, comma, infinity. Okay, and now my range is going to be a little bit different here. My range, we take a look at the vertical values, right? Vertical values. So at first we know for sure that, let's talk about this one here first for my range, this part right here, okay? So I'm going to put a parenthesis at -2 here because the circle, open circle, means it says not part of it, but that's where it starts, but it's not part of it. So I use a parenthesis instead of a bracket. And that looks like it's going to go downward towards, infinity or negative infinity, technically. Right? And then, let's erase that. It looks like an 8. So I don't want it to look like an 8. Okay? That's better. Negative infinity. And then, or it could be this piece here, which is all at 6 on the y value. So in this case, and no matter what, that is included at 6. Now we use a bracket here and say 6. Okay? So that's the quick domain in range action there. All right. So let's flip the page here now. And now we're going to look at using the graph for each function, find the domain and range of this, and then approximate the y-intercept and the zeros. Okay. Then again, we want to confirm algebraically. Okay, so let's first do it with estimating it. Okay, so the domain, what are x values? Where do they go to? Well, it looks like xy is going left and going right. Looks like left, this thing is going to extend forever left, so that would be a negative infinity. And then it looks like it's going to go to the right forever as well, so it would be a positive infinity there. Okay. And then negative 16, or so, sorry, we're getting ahead of myself. For the range, it looks like we see how low, what's the lowest point here? The minimum value there looks like negative 16. So that would be, and it's included, so that would be my low part of the range, my minimum part of the range. And then these extend on forever and ever upward. So my y is going to include all of infinity that way. Okay. All right, y-intercept. Y-intercept we know is where it crosses the y-axis. So it looks like crosses right here. So just by looking at it, I can say that's 0.0, negative 12. And that would be the y-intercept. And then my zeros, I'm just kind of estimating where does it cross the x-axis. So it looks, zeros, roots, solutions, right? Where does it cross? Looks like it crosses there and here. So I'd say that's what, negative 2. And right here, negative 2, it looks like this is 2, 4, 6. Okay. So now let's confirm algebraically the work over here on the right. So let's first find the zeros. Okay. And I guess another thing with the domains you could have said here is you could have said just a note for all reals, right? Because negative infinity to positive infinity would be all reals. That'd be fine. All right, so let's go back to the algebra. So first, let's find the zeros. Okay. So remember, I want to get a 0 for my solution. So I'm going to take the function and set it equal to 0. Okay. And then that's going to factor. So 0 equals x minus 6, x plus 2. And I'm in business there. And now if I take that and I go solve for x, I'm going to get 6 and negative 2 for my solutions. So that checked out. This was the same as here. So approximating it worked. How about my y-intercept? I can kind of look at that. These would be what we refer to as our zeros. Okay. And let's look at for the y-intercept. So for the y-intercept, let's do this. For the y-intercept. Now remember, we want to set x equal to 0 here to find out where it crosses the y-axis. So I'm going to use that function. So let's use, say it's a g function, right? So let's say I go g sub 0 equals 0 squared minus 4 times 0 minus 12. Okay, well, you can see there, obviously, I'm going to get 0 squared is 0, minus 4 times 0 is 0. So I'm just going to get minus 12. So I know right there that that is my y-intercept. Again, just pointing out, we want to put the function equal to 0 here to find my zeros. And then for the y-intercept, I'm just saying let x equals 0, and that will give you your y-intercept. All right, so 2 more. Let's get through them here. Use the graph of each function to approximate its zeros, then find those algebraically. All right. So again, looking at the graph, I'm just trying to find the zeros here. So what I'm going to try to do here is if I just kind of look at the graph off the bat here and say, okay, well, it looks like it crosses at 0. Looks like, again, it crosses here at 1 point, 1 1/3, so 1.3, we'll say, and then maybe again at 2. Okay, so that's just looking at the graph. We look good there. But now if we want to go algebraically, I'm going to extend the page just so I can work a little bit more algebraically here. Okay, so algebraically, what I'm going to do, again, I'm going to set this function here equal to 0. So 3x cubed minus 10x squared plus 8x. And I'm just going to try to solve or evaluate this. So first thing I'm going to do is try to factor something out. It looks like an x can be pulled out here. So then I'll have 3x squared minus 10x plus 8 in parentheses. And keeping going one more step down, one more step further, I've got x, and now this can factor 3x minus 4 and x minus 2. So then I know, and how do I know that? I guess we'll just kind of go a little bit further here. Just say, well, if we're not sure on that step, let's go ahead, take this and factor by grouping. Okay, so if I factor that by grouping, I end up with, let's take so just taking this whole thing right here. Okay, if I use my product sum table here, I'm going to be 3 times 8 is 24, so multiply by 24 and getting a difference of -10. So it looks like -6, -4 would have been my value. So by grouping, I would be 3x squared minus 6x minus 4x plus 8. So then I'm kind of grouping them here, and that's how I get 3x times x minus 2, and I'm going to get minus 4 times x minus 2, and that's how I get 3x minus 4 times x minus 2 to factor. So that's where I end up here, and then that means our solutions then are, our zeros would be, well, this would be a 0, and then if I set this equal to 0, it's going to be 4/3 when I do the math setting equal to 0, and this would be 2. So we were pretty close to our estimate. We had 0 correct, we had 2 correct. 4/3 is 1.33, so we were really close. Okay, all right. Let's kind of save this one for class, and we can kind of go over it just to make sure. If you want to try it, go for it. But I just want to speed this up and get this video done for you. So look and see if you can evaluate where the zeros are, and then do it algebraic. Okay. And then we will see you tomorrow.